Hello, good afternoon. My name is Jari Kapanen, and today I will introduce for you the new era of digitalization in pulp mill. And this means, in Andritz point of view, the Metris portfolio. Metris is Andritz brand name for Andritz digital solutions. And in my presentation, I will first show the basic and history behind the Metris and Andritz digital solutions, and then we go forward to Metris portfolio. So our digital journey started in 2007 when we were running the OPP service for the pulp mill customer, where the target was to optimize customer processes and take care of the automation and instrumentation maintenance. And for that purposes, we developed this kind of OPP software, which has then been the base for our Metris portfolio. Then our journey continued in 2013, for example, certain process area specific solutions like in food processing area with log scan application, where we are scanning the logs and can affect to the chip quality and forward this quality, high quality further in fiber line. In 2016 and 17, we introduced and published our Metris brand name and also included our group IT to develop more or less like a customer interaction and collaboration solution with the digital tools. Then in 2017 we continue our research and development together with research institute and collaboration between the universities, as well as our ventures team start to scout and run the pilot and POC project together with the different startup companies. And then finally 2018 we combined those digital initiative within Andritz. So we really combined the teams from automation point, so the OT technology side and the IT people and IT competencies from our group IT organization. In Andritz, we have three important strategic pillars in this digital journey. First, we are focusing on industrial IoT, which means the advanced diagnostic for the key process equipments, and then further analyzing the data out from the diagnostic systems. Then we have this smart service initiative where our IT guys and software development guys are developing those collaboration tools for the customer. And one example of that is the customer care portal or spare part catalog, where customers can browse installed base easily and look what kind of parts we can offer for them. And both of these pillars are supported by our ventures team, who are really organizing those cooperation possibilities with the startup companies and universities, for example. If we look those different kind of technologies what we are using in this journey, we are first investing to the sensor technology. So sensoring and this we are doing because typically the process values are quite well collected and combined and aggregated, but then the specific wearing and condition monitoring and diagnostic data, for those we need to develop and install new sensors to sense what the machines are really feeling and what is the wear rate of the machines. Then we see that we need the data analytic tools, and this we are calling like a big data, and it contains machine learning, artificial intelligence applications where we can manage and handle and modify the collected data. And finally, we need tools how to visualize and make the new findings available for the operators and other stakeholders. Then when we can get the new information, the customer can utilize those for the condition monitoring, for example, process optimization, or then we can combine this kind of smart service agreements with the customer where we can cooperate and collaborate by utilizing these digital tools. The enablers, what we see in this digital environment is really the different kind of computing system. They can be on edge systems which are running on site and on maybe even next to the process machines. And then as a parallel, the cloud environment where we can, for example, aggregate the data and store the pictures, etc. It's really the way how we can share the information what we are producing with these subsystems. And of course, this kind of artificial knowledge based is really based on the findings and based on the analytics what we are offering for our customers. Then if we go more in Metris portfolio, we can say that Metris is really all-in-one digitalization platform, and it based on the applications like our mobile phones or tablets are nowadays, and we have a different applications for different purposes, so that you can select those from App Store what kind of applications you need and build your own environment inside the Metris. Then we have a Metris X, which is really the control system for Android, and it's Android's brand name for the DCS. And if we think this in application point of view, it means that we have a Control Studio app where we are designing the control strategies and then process display where we are presenting the displays for the operators and for the field users. So how we are designing the HMI for the end users. And all this we can offer as a Metris OPP service agreement, which means that the Android personnel are optimizing the customer processes together with customer and utilizing all the Metris applications and tools what we can offer. If you look the main characteristic of the Metris platform, first there is those applications which you can find from integrated App Store, and this is really so that it's on demand when you can select the certain applications to be used. It's really the scalable, this kind of modular concept gives a possibility that you can start with a small machine and then expand it for the plant-wise solution, and you can create this kind of seamless user interaction. All the data between the applications and different solutions are fully transparent, and you can utilize the data from different applications to each another back and forward. So about the scalability, the Metris can run in Raspberry Pi application in one small equipment and up to pulp mill where the whole pulp environment together with power distribution and power generation is combined. And this application architecture gives us really the possibility to have a seamless interactions and data transfer between the applications. And it offers different kind of tools for the collaboration as well as AI application. An AI approach inside the Metris application is so that we are focusing on machine learning. It can be the supervised or unsupervised machine learning. We are utilizing different kind of methods there. And the other part is really the collaborative way how you can utilize the machine learning to create your own models and soft sensors, for example. We have created this kind of wizards where the normal operators or operational directors can create them own applications. If we summarize the Metris UX platform and functionalities, it based on the application. One of the application is the Metris X under DCS system. It contains modules for the condition monitoring. We are offering the smart services for the collaborative tools. We can optimize the process performance with these tools. You can connect your plant into the Android environment by Metris Performance Center. Metris platform includes the virtual assistant, which guides you and operators through different applications, how to run the application, how you can find the functionalities out from the application. It contains the cybersecurity tools, and then you can create the digital twin of your plant with the Metris application. Thank you very much, and I will be available for further questions. Thank you.
Hi, my name is Marcio Silveira, and today I would like to talk about the evaporation plant and recovery boiler optimization utilizing model predictive control technology. This is a project that was implemented at Suzano Três Lagoas mill, located in Mato Grosso do Sul, Brazil. Our agenda is to talk about a little bit of the evaporation and recovery boiler areas at Suzano Três Lagoas. Then we will discuss a couple of variables which will impact on recovery boiler steam ratio. Steam ratio is a measure of how much steam you can produce by each ton of dry solids that you burn in the recovery boiler. Then we will go into the details of the evaporation plant advanced control, followed by the recovery boiler advanced control, and I will wrap up telling the conclusions that we can take from this work. So Suzano Três Lagoas is one of the largest mills in Brazil. They have the capacity of producing around 3.3 million tons of bleached eucalyptus pulp per year with 2 lines. The first line was or had its operation starting in 2009. Meanwhile, the second line started operating on 2017. On this image, I have highlighted in yellow where is the evaporation plant for line 1, and in green, where is the evaporation plant for line 2. Line 1 evaporation plant capacity is 1,250 tons of water per hour using 6 effects and ash leaching as its acid treatment system. For line 2, that has a capacity of 1,950 tons of water per hour with 7 effects. Instead of ash leaching, it will use a crystallizer for its ash treatment. The recovery boilers are both really big. The first one, for the line 1, has a capacity of 6,000 tons of dry solids per day with 3 electroprecipitators, while the recovery boiler on the second line can burn up to 8,950 tons of dry solids per day with 4 electroprecipitators. They have one power boiler that has a capacity of producing 150 tons of steam per hour, and the biomass type is primary sludge, mixed sludge, bag, and chips. Tres Lagoas has a surplus of electricity that is produced with both lines running, and what makes electricity to be a high regarded product for the mill, and increasing their capacity of producing more electrical energy to sell to the grid is a big source of revenue for them. So we have studied all the process and we rank the ones that would bring most benefit for them. And that's why we selected both the evaporation plant and the recovery boiler to implement advanced process control solutions that would help them increase their capacity of generating more electrical energy to sell to the grid. With that in mind, the main KPI for both projects and for the whole idea behind it is steam ratio. And like I said before, it's just a measure of how much steam you can produce by every single ton of dry solids that you burn in the recovery boiler. So basically in the recovery boiler, you have black oil liquor coming in air, and that will generate green liquor, steam, and combustion gases. So the steam ratio can be affected by a couple key parameters, as you can see on the right. The first one is the head black liquor dry solids. And as you can see, the higher the dry solids content, the higher is your steam ratio. So that's what the evaporation plant APC would tackle. The other one that we saw, and it's really important for increasing their steam generation, is the residual oxygen in the furnace of the recovery boiler. As you can see, the lower is the oxygen, the higher will be your steam generation. And the last one that you checked is the impact of the sulfidity of the liquor in the steam generation. And the higher is the sulfidity, the lower will be your steam generation. And it was important for us to understand what was the impact of the sulfidity, because during the implementation of the project, they were running a little bit higher sulfidity than before, averaging something around 34. And we needed to understand, whenever we were checking if the controls were able or not to increase the steam ratio, if that was not an effect of having a lower sulfidity that month or something like that. Well, we selected model predictive control as a technology to use to implement the controls here. And the MPC is nothing more than an algorithm which uses a set of linear dynamic models representing the process to predict the effect of future control moves on the output variables. An optimization routine is used to compute a set of future control moves such that the performance index is maximized. So it is a multiple input, multiple output controller. And for the evaporation plant MPC, the idea behind is to use a control that will account for the interactions between the steam flow, product solids, and feed solids, that will try to compensate for any disturbance from the upstream process, such as changes in the brown stock washing. The control will kind of understand how the fresh steam usage, feed liquor solids, and product solids will respond to the process changes. And using that built-in knowledge, it will improve the evaporator economy, stabilizing the product solids, and making it possible to maximize it to a desired level. Since it's an MPC, it's a model-based control, we will have a control matrix. in every control matrix, we have different types of variables. So the manipulated variables are the ones that we actually use as handles of the process, is what we are actually and actively sending new set points, trying to make our control variables being on target. And the third type of variables are the feed-forward ones that will tell us about known disturbance to the process that we have to compensate somehow. For the evaporation control, the first line has 6 effects. However, the only effect that is receiving live steam is the first one, also known as concentrators. The first effect is divided in 4 stages, 1D, 1C, 1B, 1A. And the control will be basically handling how much steam we are adding to every single stage of the first effect. And our 5th manipulated variable is how much steam, how much liquor flow we are sending to the concentrators. As control variables, we are using estimated solids for every single stage of the first effect, and we are estimating the dry solids for those stages using boiling point rise, short for BPR. And the BPR is basically the new boiling temperature of the liquor that will be higher than the water, and the difference between the boiling point of the liquor compared to the boiling point of the water will correlate with how much solids you have in the liquor. And of course, we also have a refractometer going out of the evaporation plant that we use to check if we are achieving the final head black liquor dry solids target. And we also add a constraint variable in as the header pressure of the first effect to keep it within limits and to ensure that we are not compromising the efficiency of the plant. And the most interesting part of the MPC for the evaporation train is that we can use the estimated dry solids of the previous stage as a feed forward for the next one. So we are tying together all the stages into a single control. Implementing the APC on the evaporation plant, we were able to increase the dry solids contents from 81.2% to 82%, which means a 50% reduction on the variability of that liquor. We used the 2-sample t-test to check if the results were statistically significant when comparing the period of time they were running the controls with our baseline reference time. And the other point that we were able to see is that even increasing the target of the head black liquor dry solids, we didn't increase the amount of excursions with really high dry solids that can be also a problem for the process, as you can see in the histogram down below. So when we check the steam ratio, after implementing the evaporation control, we could see that we were able to increase it from 3.201 to 3.238, an increment of 0.037. That is basically because having have black liquor with a greater dry solids content, it has a greater calorific power as well. So we can produce more steam with the same amount of liquor. Now, the recovery boiler control also has its own matrix, and the whole idea behind it is now that we have a better quality head black liquor, we will also have to optimize the recovery boiler to achieve a lower furnace oxygen, and that will also increase my steam generation. To do so, our main handles for the oxygen will be tertiary air and high secondary air. However, we also have as manipulated variables the primary airflow and the low secondary airflow, the head black liquor flow, that is also known as boiler load, and the steam injector valve opening. And the idea behind here is that all air levels will get a target from an air curve that will calculate how much air we should be using for the specific boiler load that the operator is targeting. However, the tertiary air and the high secondary air will change a little bit and deviate from that target to make the oxygen reach our target. And we are also controlling the steam injector, so we can have the black liquor temperature on target, and that target is calculated based on the dry solids content of the liquid. After implementing both controls, what we were able to see that there was a real increase on the steam generation, as you can see on the first top left chart. The recovery boiler load average out quite similarly throughout the time, but we were able to change how the steam ratio was trending. So before the controls, it was decreasing, and after we implemented both controls, it started trending up. And the main reason for that is because we were able to reach a higher average of black liquor dry solid, as you can see on the top chart on the right, with a lower residual oxygen over time, and as I said in the beginning, with a little bit higher sulfidity. So even knowing that the sulfidity would make them produce a little bit less steam, but it would help them with the pulping process and increasing the yield in the pulp production side with a better evaporation plant and recovery boiler controls, we were able to increase their steam generation. The recovery boiler results is quite good as well. We were able to decrease their residual oxygen from 3% to 2.3%, and we achieved a 56% reduction on the variability of the oxygen when under control. And we also use the 2-sample t-test to prove that those numbers are statistically significant when comparing the period of time that they had the control running with our reference baseline period. Therefore, we can say that after implementing the controls, we were able to increase the steam ratio generation from 3.294 to 3.342. And using both controls, we calculated an increment of 0.085 tons of steam per tons of dry solids burned in the recovery boiler, which represent a 2.7% improvement over the baseline. This increase correlates to an incremental economic benefit of around 137,000 tons steam per year, which can be converted to roughly 39,000 megawatts per hour, what can represent an estimated revenue of $2 million USD per year. I would like to thank Suzano Tres Lagoas automation team and evaporators and recovery boiler operators for providing the support necessary to implement these applications. Thank you very much.
Good afternoon, ladies and gentlemen. Welcome to the last session of the day. Congratulations to Jari and Marcio for the great presentations. Today we are here discussing important topics as digitalization, optimization, and of course, Industry 4.0. I would kindly ask if it's possible to send some questions to our form, please. We would like to introduce some topics. And when we are waiting for these questions, maybe I can introduce to Marcio. Yesterday, our Secretary of State for Digital Transformation, Mr. André Aragão, he said, he refers that the collaboration inside ecosystems is essential for digital transformation. How do you see this, Marcio? How do you see the collaboration between the different ecosystems in our industries nowadays?
Well, that's a really good question and a kind of complicated one to answer. Nowadays, we have many different platforms doing very similar things from different companies. And what we have to achieve is a way to make it possible for our tools to be able to communicate with a broad, different platforms, for example, different DCSs, different equipments, and everything. So moving forward to creating standards and trying the solutions in different places will help with that. But it's essential that there is a good interaction with different tools.
All right, thank you. Maybe for the next question for Jari, let me just introduce something that I read just this week in the Harvard Business Review. Very interesting story about artificial intelligence, where power factories will have jobs for humans. Very in briefly, it was a Tesla in California, complete new mill, fully automated. And the target was that we will produce 5,000 car per week. In the end, they could only produce 2,000. And then Elon Musk realized that to reach the 5,000 target, they have to combine and mix robots with humans. Of course, these humans, they need to have a lot of particularities, very special skills and trainings. So my question to you, Jari, is what kind of skills do you think for our pulp mills in the future do we need to be able to use all these new digital products that we are bringing to our customers?
Okay, thank you for your question. Really interesting question and actually very actual. It was one couple of hours ago I had just a discussion about the future operator and what kind of skills and actually what kind of background our future operators might have. And we were discussing that, okay, the young generation which is now entering as operators, they have played video games all their lives. And maybe this makes it a little bit easier that they are used to make things happen through the HMIs, through the digital interfaces. But really, when we are going forward with the autonomy of the mill, I think it's not a challenge for the operators, but it's a challenge for our system suppliers, that how we are informing the most critical items for those operators who are operating both on field and both in control rooms in the future.
All right, thank you. Okay, now I can see some questions coming from the audience. Maybe one from Marcio. How does the evaporation application taking into account falling of the concentrators?
Well, we will realize that the concentrators are falling whenever we see that it's harder to achieve the same PPR that we had previously. The system will understand that and see the product solids for that specific stage dropping, and it will try to compensate with a little bit more C. Of course, it needs to be within the constraints of the controls. And of course, the operators have the automatic washing sequence. They are always washing more the stage that usually fall more rapidly. And but anyway, for the control itself, since it sees the product solids or estimate the product solids for each individual stage, it will compensate for the following along the campaign.
All right, very good, thank you. The next question for Jari. Could you explain some examples in real life that Anders has running with Matrix, and what are the areas in a pulp mill when applying the concept is expected more returns, for example, cooking, bleaching, or recovery boiler, etc.?
The most common thing how we are utilizing the metrics is those OPP service agreement, and it covers the whole mill typically. And the first step is that we are evaluating the area where is the biggest potential, and that's the way how we are proceeding with the OPP agreement. And the main thing how we can improve the efficiency is really those advanced process control. And what is the technology behind? We are using the similar predictive controls or multivariable controls. It depends on the area what we are optimizing. But I can say that in general we can start the process area where is the biggest potential, and to implement advanced process control is the quickest way to get the savings.
Very good, thank you. Another one from Marcio. Have you seen any impact on the boiler plugging?
No, one of the things that we noticed and we actually accompany very closely during the implementation of this product, this advanced control, was the pressure differential in the boiler bank region. And for most of the time, the slope it was increasing, that is showing that boiler is getting full over time, didn't change compared to the same period of time that were analyzed without it. So there is a concern about reducing too much of the tertiary air, and that kind of decreasing the ability of the tertiary air to not allow the full go to the boiler, the superheaters or the boiler bank, but we didn't observe that in this particular case.
Okay, thank you. For Jari, in your presentation, you talk about condition monitoring. Can you go a little bit deeper how you are doing this system?
Like the other applications inside our Metris platform, condition monitoring is one of those. And one example of the condition monitoring is that we are implementing our own sensors. It's called Metris Vibe. It's a 3D vibration sensors together with the temperature measurement. And by installing those into the critical points of the process equipment, we can go forward for predictive maintenance and improve the availability in that sense. That's the one example.
Okay, thank you. Marcio, what is the impact regarding the boiler's reduction degree?
The reduction degree for this boiler was already quite high and quite normal for a boiler of this size. Line 1 at Três Lagoas, although is older than the line 2, is not that old, and we didn't see an increase on the reduction degree or a decrease in the numbers. But we must remember that we don't have laboratory results showing the reduction degree that often, so it's kind of hard to compare that with short average, having the test once per week or so. But there is no difference in the numbers prior to the control or utilizing the controls.
Okay, I only have one more question. It's also for Marcio. In the process of optimization of the evaporators, how the system handled the variability of the weak black liquor system upstream? Example, cooking, washing, and bleaching.
So the feeding black liquor, the weak black liquor solids, we use as a feed forward to the control. So whenever the control realized that the number itself was decreasing, that would cause our predictions for the product solids on 1D, that would be the first stage of the concentrators, to also decrease, and that would cause the control to respond, adding a little bit more steam to that stage.
All right. So let me just make sure there is no other questions. Okay, I think we still have some minutes now. It's up to us. So maybe we can share some of our experience. So Jari, what about in your implementations? You said that you've been implementing OPP in several mills. what are your main difficulties when you start from scratch and you are implementing such a project like this? What are your main challenges from start to the results?
Of course, it's. I think this is a human impact. In our OPP agreement, we have our local guy on site. That's the concept, that we have 100 personnel on site, and for him that he is really collaborating and working as a part of the customer, so really together with the customer. This is the hardest point, and of course to encourage the customer to openly saying that what is the biggest bottleneck at the moment. So evaluating the biggest potential each and every time. I think those are those biggest challenges.
May I tease you, for example, Renato, what about the integration with the different systems, getting data resources for a lot of different places? How are you handling this?
That question was for me?
Yeah, Renato.
Okay, sorry. Usually most of the communications that we use in our systems are OPC based. So whatever we need is basically a OPC DA or UA server on the other side, and that we would bring the information to our system. If there are multiple sources, then we will use a sort of integrator that we will link all the different connections to a single point in our side, and then from that point on, we send information to our controller.
All right, very good. So far, I don't think there is no more questions. So I think that's it. This is the last session of the day. I would like to thank Jari and Marcio once again for the great presentations and for the good discussion. I think digital has been covered as one of the biggest enemies of paper, but we can easily show here that can also be one of the biggest allies for the future when we are talking about efficiency and turns our mills in a better way. So I would like to thank you. Thanks, Tecnicelpa, for the invitation. And of course, if you want to continue to know a little bit more about digital, don't hesitate. Look for other topics on the conference bags, on the oral communications, on the posters, and of course on our websites. There is a lot of information. Thank you.
Yeah, thank you from my side also. Thank you very much.
Thank you.